Okay, we'll see chapter 39, alternating current. Question for the short answers first. Let's see question number 1. What is the reactance of capacitor connected to constant DC source? The answer is infinite because reactance is inversely proportional to F. For DC, F is 0. Therefore, reactance will be infinite. It offers infinite resistance to DC source. Therefore, current doesn't flow. That case. Next one is question number 2. The voltage and current in series AC circuit are given by this relation. One is cosine function, other is sine function. What is the average power dissipated in the circuit? Average power dissipated in the circuit will be 0 because phase difference between sine and cosine function is pi by 2, and average power is given by this relation. Instantaneous power will also be 0. Okay, we are talking about the average power. All right. Next one is two alternating currents are given by this relation. This is pi. I1 is given, I2 is given. Will the RMS values of current be equal or different? It will be equal. RMS value depends upon the peak current, which will be divided by √2. That will be RMS current. Equal in both cases. Can the peak voltage across the inductor be greater than the peak voltage of source in LCR circuit? Yes, it can be possible. At resonance, we can see that we can calculate it can be more than the applied voltage. In circuit containing capacitor and an AC source, the current is 0 at the instant the source voltage is maximum. Is it consistent with the Ohm's law? Ohm's law is valid for the resistive loads only. For resistors, it is valid. Capacitive load and inductive load, it is not valid. So it is no question of consistency with the Ohm's law here. An AC source is connected to a capacitor. Will the RMS current increase, decrease, or remains constant if dielectric slab is inserted into the capacitor? Okay, it will increase because I is inversely proportional to reactance, and reactance is inversely proportional to dielectric constant and C. Therefore, ये value यहाँ put कर देंगे. So I will be directly proportional to Kc. K is more than 1. Therefore, current will increase. Since this side is increasing, current will increase. All right. Next one is when the frequency of AC source in an LCR circuit equals the resonant frequency, the reactance of circuit is 0. Does it mean there is no current through the inductor or capacitor? No, there is the current in the inductor and capacitor, both. In fact, maximum current flows in LCR circuit at resonance of LCR series circuit, because I will be Vrms upon Z, but Z will be equal to R at resonance. All right. Next one is when AC source is connected to capacitor, there is a steady state current in the circuit, does it mean that the charges jump from one plate to another plate in the circuit? Answer is no. There is displacement current between the plates, which is due to the changing electric field. और डिस्प्लेसमेंट करंट होता है गैप में, चार्जेस जम नहीं करते उसमें. ऑलराइट, नेक्स्ट वन इज displacement current. In fact is for displacement current we will be covering it in the chapter of EM waves, electromagnetic waves के NCERT book के electromagnetic waves के chapter में displacement current के बारे में we are going to study. Current I1 is given by this relation, passes through a resistor of resistance R. How much thermal energy is produced in one time period? A current I2 is minus of previous one, passes through the resistor. How much thermal energy is produced in one time period if I1 I2 both passes through the resistor simultaneously? How much thermal energy is produced? Is the principle of superposition obeyed in this case? Okay, thermal energy per second, in fact per second निकाल लेते हैं, heat we can call it power, thermal energy per second or power. Okay, IRMS. Okay, IRMS इसको V is equal to IR H is equal to cos phi 1 होता है I square R आएगा. V को चेंज किया तो यहाँ पर ओके लाइट ओम्स लॉ से R के टर्म्स में तो I V is equal to IR, तो ये IRMS into R into IRMS into 1, तो ये हो जाएगा IRMS square into R, which can be written as I naught square by 2 into R. H1. Similarly, P1 कर लो heat per second energy P1. Similarly P2 में भी same situation है. And when we put supply both together, this is plus, this is minus, cancelling effect. एक ऊपर oscillation हो गया, एक का नीचे, zero हो जाएगा, net current will be zero. तो power will be zero. Power heat per second, power will be zero. Yes, it obeys the principle of superposition. All right. 9th हो गया. 10th is energy produced when the transformer steps up the voltage? No, voltage बढ़ता है तो current decreases. The current decreases, energy remains same if no other losses. Energy कभी नहीं बढ़ा सकते. We cannot produce the energy. We can convert from one form of energy, one form to other form. बढ़ा नहीं सकते. We cannot produce it in any case. Not only that. Next one is a transformer is designed to convert an AC voltage of 220 volt to an AC voltage of 12 volt only. If the input terminals are connected to DC volt or 220 volt, the transformer usually burns. Explain why. Because resistance of capacitor winding is resistance is of copper winding. Resistance of copper winding is very small, and large current will flow. Because of that, it burns. Primary and secondary windings are made from the copper. All right. Can you have an AC series circuit in which there is phase difference of 180 between the EMF and current, or 120? No, not possible, because tan phi is XL minus C by R, and from which phi can be between minus pi by 2 to plus pi by 2 and equal to that. It can range from this, cannot go beyond this, from this relation. ठीक है, इस रिलेशन से इसके बीच में होगा. Okay. Resistance is connected to AC source if the capacitor is included in the series circuit. Will the average power absorbed by the resistance increase or decrease? Okay, capacitor include कर दिया, so Z will go up, current will come down, therefore average power will decrease. All right. If an inductor of small inductance is also included in the series circuit, will the average power absorbed increase or decrease further? कैपेसिटर लगा देंगे तो ये वैल्यू कम हो जाएगी, Z will reduce, therefore current will increase, average power will increase. All right. Next one is, can a hot wire ammeter be used to measure the direct current having constant value? Do we have to change the graduations? Yes, hot wire can be used to measure the RMS current, which is constant and equal to the DC. RMS current जो है DC के equivalent होता है as far as heating effect is produced. That produces the same heating effect. RMS will be equal to DC. That will indicate yes, and we don't have to change the calibration because RMS is defined on the basis of DC only in terms of heat produced in the same resistance in same time interval. So we don't have to change. That's all. Then we'll continue for the next questions in the next lecture. Thank you.